Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 17, Mixture Problems. Classwork, opening exercise. Imagine you have two equally sized containers. One is pure water, and the other is 50% water and 50% juice. If you combined them, what percent of juice would be the result? Okay, so amount of liquid gallons, first liquid. So let's do that in red. One is pure water. Amount of liquid in gallons. So imagine you have two equally sized containers, so they're 1 gallon containers. So I would say first liquid, amount of liquid 100%, or simply 1. And amount of liquid gallons in the other second liquid is 50-50 water juice, but that's all liquid, so that is 1. So the resulting liquid is 2 gallons. We have 2 total gallons. We have a gallon of pure water, we have a gallon of 50-50 mixture water and juice. Okay, so now it says amount of pure juice per gallon. So in this one, there is no juice, it's pure water. So the amount of pure juice would be 0 because 1 gallon of water, or 1 gallon of liquid times 0% juice is 0. If we're going to do quantity equals percent, 100% times the whole. And in the second liquid, we have amount of pure juice, second liquid, is 0.5 because 0.5, 50% of 1 is 50%. So if we take the quantity is equal to the percent times the whole. So 50% of 1 gallon is 50%. So the resulting liquid is 0.5, which equals x plus 2. Because the quantity that we just came up with, Q, is 0.5. And we want to know some value and add it to the 2 resulting liquids. So that's the percent. This is our percent, our x, times, oh, it's not plus 2, it's times 2, times 2. Okay, or percent times whole. So we have x times 2. We don't know the percent, but we know the whole. Resulting liquid is 2, and we know the quantity is 50%. So now in order for us to find our x, then we would solve that. So it would be 0.5 equals x times 2. And if I divide both sides by 2, then I get 0.5 divided by 2, which equals 0.25, or 25%. Okay, now it says if a 2-gallon container of pure juice is added to 3 gallons of water, what percent of the mixture is pure juice? So we are going to let x equal the percent of pure juice. And this is in mixture, the resulting mixture. So if I just said percent of pure juice, well then you would say 2-gallon container of pure juice, that's 100%. X is going to be what we're finding. What is the percent if 2 gallons of pure juice is added to 3 gallons of water? So the amount of liquid in gallons, the first liquid, the 2-gallon container of pure juice, is 2. So the amount of pure juice is 2.0 because that is 100% times 2 gallons. So the amount of pure juice is 2. So what did we do? We took the quantity of pure juice equals some percent times the whole. And we knew it was 100% pure juice, so that's 1, or 1.0. And that's not a decimal, so let's do parentheses. Okay, now the second container of liquid, it's added to 3 gallons of water. So the second liquid is 3 gallons. And this is going to have 0% juice because 0% of 3 is 0. Because that was our quantity. What are you doing? That was our quantity. And this is our percent, 0% times our whole. Okay, now the resulting liquid is, what's the total? Well, the total is 5 gallons. So we're going to take the quantity of pure juice, which is 2, and that is going to equal some percent. Let X be the percent of pure juice in the mixture times the whole, which was 5 gallons. So that is our quantity equals our percent times our whole. So when I solve this, I say 2 equals X times 5, divide both sides by that 5, and we get 2/5, which is the same as 4/10. Oh, come on. Or 40%. Okay, continuing. If a 2-gallon container of juice mixture that is 40% pure juice, so a 2-gallon container of juice mixture, so what we're going to do is we're going to mix this pure juice with 3 gallons of pure water and getting a 5-gallon mixture that's 40% juice. We're now going to take 2 gallons of that mixture of the 5. We're going to take 2 gallons out. So a 2-gallon container, let's change colors. A 2-gallon container of juice mixture that's 40% pure juice is added to 3 gallons of water. So the first liquid is 2 gallons. The second liquid is the water, and the result would be 5 gallons of a 40% mixture of juice water to pure water. So again, we're going to do amount of pure juice, and that would be some quantity equals some percent times the whole. Well, we're trying to find the quantity, and the percent is 40, so that's 0.4, and the whole is 2 gallons. So 40% of 2 gallons is 0.8, or 80%. Then if we do this again, we have some quantity equals percent times whole. Well, I know the whole is 3, and the percent of juice in this pure water is 0, so the quantity of juice in this mixture is 0. Then we're going to do it one more time. Quantity equals some percent times the whole. The whole is 5. The percent is going to be X. We're going to let X equal percent of pure juice in this mixture. And we're trying to find the quantity. So how many gallons of juice mixture is pure juice? 0.8 gallons. So that would be 0.8 equals X times 5. So if I divide both sides by 5, then I get X equals 0.8 divided by 5 is 0.16, or 16%. And then finally, if a gallon of juice cocktail that is 40% pure juice is added to 3 gallons of pure juice, what percent of the resulting mixture is pure juice? Okay, so the liquid, first one, is 2 gallons of juice. And it's 40% liquid, so if I take my equation, some quantity equals percent times whole. The percent is 40%, which is 0.4. The whole is 2, so my quantity is 0.8 or 80%. The second liquid is 3 gallons of pure juice. So if we use our equation, quantity equals percent times the whole, we know the whole is 3. The percent is 100 or 1, so my quantity of juice in that is 3. And then the resulting liquid, well, if I add 2 gallons of 40% pure juice to 3 gallons of pure juice, I get 5 gallons of some sort of dilution. And Q equals P times W again. The whole is 5. We're trying to find the percent X, and the quantity is 0.8 plus 3. Because this is pure juice, we want to add these two this time, so this is 3.8. If I divide 3.8 by 5, then X equals, now there's a trick to dividing by 5. Dividing by 5 is the same as multiplying by 2 and moving the decimal. So 38 times 2 is 76, and move the decimal one place to the left, so X is 0.76 or 76%. Example 1. A 5-gallon container of trail mix is 20% nuts. Another trail mix is added to it, resulting in a 12-gallon container of trail mix that is 40% nuts. That's just nuts. A, write an equation to describe the relationships in this situation. So we need a variable. So let's just let X represent the percent of nuts in the second trail mix that is added. Percent of trail mix in second. Percent of second mix. How can I word this? Let X represent percent of nuts in, I'm not writing very well here, in the second trail mix. That is added to the first to create the resulting 12-gallon container of trail mix. So we're going to start with that equation, some quantity equals percent times whole. Okay, so we have to give this a little bit of thought. We're talking about 40% of 12 gallons. That is our quantity we want to find. So that is going to be 0.4 times 12. Our percent is that we already have is a 5-gallon container of trail mix is 20% nuts. So that's 0.2 of 5 plus, so we're not doing the quantity equals percent times whole. We have to do something differently here. So what I'm doing is I'm taking our result, 40% of 12 gallons and 20% of 5 gallons, and then we don't know the percent of nuts in the second trail mix, but the second trail mix is 12 gallons minus the initial 5 gallons, and I'll just write that as 12 minus 5 for now. Okay, so let's recap. So 40% of 12 gallons we were given. 20% of 5 gallons we were given. It says, how do we write an equation to describe the relationship in this situation. So here's the equation. So we have the first trail mix, which is 20% of the 5 gallons. And then we have the second trail mix, which is some percent of 7 gallons that resulted in 40% of 12 gallons. Okay. Now it says to explain in words each part of the equation. Okay, so quantity equals percent times whole. So we take the resulting gallon of trail mix times the resulting percent of nuts, that's our quantity, equals the percent first trail mix in gallons times percent of nuts plus second trail mix in gallons times percent of nuts. What percent of the second trail mix is nuts? So now we're going to solve this equation. So I take 0.4 times 12, this right here, which is 0.48, equals 0.2 times 5 is 1, plus 12 minus 5 is 7x. Okay, so now we want to solve for x. So we're going to subtract 1 from both sides. And 0.48 minus 1 is negative 0.52 equals 7x. Oh, my decimal's in the wrong place. Time out. 0.4 times 12 is not 0.48, it's 4.8. There's only one decimal. So let me fix that. It's 4.8. So now when I subtract 1, I get 3.8. The reason I pause there, and I always say this, when you're working problems, when you get an answer to something, does it make sense? When I got a negative, we can't have a negative value if we're talking percentages. So I realized there was an error somewhere, so I went back and reviewed my work. Don't just come to a conclusion, get an answer, and say, oh, the answer is negative 45, and it makes absolutely no sense. Negative 45% of nuts is in this container. Well, you can't have a negative quantity. Okay, so 3.8, now we want to divide by 7. And x equals, let me get my calculator. Okay, here we go. 3.8 divided by 7 is 0.543 approximately, or 5429. So 0.5429, which is 54.29%. Approximately. Since I rounded, I'll use the approximate. Okay, exercise 1. Represent each situation using an equation and show all steps in the solution process. Pause the video, see if you can do these, then come back and see how you did. Okay, here we go. Represent each situation using an equation. A 6-pint mixture that is 25% oil is added to a 3-pint mixture that's 40% oil. What percent is the resulting mixture of oil? So we have a variable x. So let x represent the percent of oil. The percent of oil in resulting mixture. Okay, so we take this 0.25 times 6, that's our quantity, equals, is added to, plus 3-pint mixture that is 40% oil, 0.4 times 3. And that is going to equal the 6 plus the 3, the total gallons, times some percent x. So 6 times 5 is 30, carry the 3, 6 times 2 is 12, 13, 14, 15, so 0.25 times 6 is 1.5, plus 1.2 equals 9x. 1.5 plus 1.2 is 2.7 equals 9x. Divide both sides by 9, and x equals 0.3, or 30%. So the 9-pint mixture of oil has 30%. Part B, an 11-ounce gold chain of 24-karat gold was made from a melted down 4-ounce charm of 50% gold and golden locket. What percent of the locket was pure gold? So now we're going to let X represent the pure gold in the locket. Okay, let X represent the percent of pure gold in the locket. So the first thing I do is we have an 11-ounce gold chain of 24% gold. So that's 0.24 times 11 ounces. It's melted down from a charm and a locket, so that's our total. And we know that 0.5, 50% of 4 ounces, and the locket, which is going to be 11 ounces minus the 4 times some percent X. Okay? Just making sure this is all correct. And then I take 0.24 times 11. Let's just do this quickly. $2.64 equals 0.5 times 4 is 2, plus 11 minus 4 is 7x. Okay, I'm going to subtract 2 from both sides, and I get 1.64 equals 7x. Divide both sides by 7, and I'll finish over here, and I get x equals 7 times 2 is 14 with a remainder of 2, and 7 times 3 is 21 with a remainder of 3, and 7 times 4 is 28 with a remainder of 2, and 7 times 2 is 14, and so on and so on. Or if I just go like this, 1.64 divided by 7 is 0.23428, rounded up is to 9. Let's just go out 4 decimal places. Oh, it's 0, silly. All right. So 0.64 divided by 7. 0.64 divided by 7 equals. Okay. Before I erase this, let me explain why I questioned that. X is the percent of pure gold in the locket. I got an answer greater than 1, and I'm like, what? So then I went back and I noticed that I made a mistake here. You can't have more than 100% pure gold in a mixture. It made no sense to me. So I went back, found that I had made a mistake in my subtraction, and fixed it. And it's 0.914. Or approximately Okay, part C says, in a science lab, 2 containers are filled with mixtures. The first container is filled with a mixture. First container is filled with a mixture that's 30% acid. The second container is filled with a mixture, 50% acid. And the second container is 50% larger than the first. The first and second containers are then emptied into a third container. What percent of acid is in the third container? So first, let's let some variable x equal total amount of mixture in first container. Okay. So let x equal... Okay, that was a little sloppy, so I changed it to text. Let x equal total amount of mixture in first container. All right, so now what are we going to do? 30% of some value, so 0.3x is the amount of acid in the first container. Okay, so we don't know the total container amount, which is x, but 30% of that unknown total is acid. All right, so 50% of the second container is acid, so it would be 0.5, 50% of the mixture plus 0.5x. Okay, so it says the second container is filled with a mixture that's 50% acid, so it's 50% acid, and the second container is 50% larger than the first. So this is 100% the first container, and this is another 50%, or I could have just said 1.5x, but I'm just showing everything for now. Okay, that is the amount of acid in second container. Okay, so now we need to come up with an equation. We need to add these two, because it says what percent of acid is in the third container, which is the total of the 2 containers. So we would say 0.3x plus 0.5, 1.5x, I just added these two, equals let's see, I don't want to do it equals, let's just work it vertically. So 0.3x plus 0.5 times 1.5x is 0.3x plus, well, 5 times 5 is 25. That would be 0.75x. 0.5, half of 1.5 is 0.75. And then when I add these two, 0.3 plus 0.75 is 1.05x. And that is the amount of acid in the third container. Okay? All right, so now we need to solve this. So we take x, first container, plus second container equals 2.5x. That is the amount of mixture in the third container, right? That's the amount of mixture in the third container. So then what we can do is take 1.05x, the amount of acid in the entire container, because it says what percent is acid. So the x's cancel, and if I go to my trusty calculator and say 1.05 divided by 2.5, I get 0.42. Okay, 0.42. Had a little problem with my computer there, and I thought I paused this for that delay, but I guess not. All right, sorry for the delay. The suspense was killing you, I'm sure. So now we end up with 42% is the percent in the third container. Okay, example 2 says, soil that contains 30% clay is added to soil that contains 70% clay to create 10 gallons of soil containing 50% clay. All right. So we take first soil amount. I'm going to call it S sub 1. And I'm going to multiply that by percent of clay. Okay, I don't want to write out soil, first soil amount, second soil amount. So let's start using subscripts here. So S sub 1, soil from the first soil amount, times the percent of clay. So I'm going to take that amount, and I'm going to multiply, I want my percent, or my parenthesis here. So it's soil from the first soil amount times the percent of clay. And then I'm going to add, is added to the second soil amount, I'll call S sub 2, times the percent of clay, to create resulting amount, let's call it R, times resulting percent of clay. All right, so now we just fill this in. Well, S sub 1, we don't know, so we'll just leave that. We'll call that X. Percent of clay in that is 0.3. And we're going to add that to S sub 2, which is, the total's 10. Okay, so if my first soil amount is some unknown and my total is 10, the second soil amount is the total minus the first. That makes sense? Okay, so it's 10 minus X times some percent of clay, which is 70, which is 0.7, and that is going to equal 50% of 10. Okay, so the resulting amount is 10, and the percent of clay was 50%, or 0.5. Okay, so now we have our equation with variable x, and we can solve by simplifying, combining like terms, and all that. So the first thing I'm going to do is rewrite this as 0.3x plus, and then I'm going to distribute and put them in the proper order. So 0.7 times a negative x is going to be minus, so it's going to be, well, let's leave it in the order. So that'd be 0.7 times 10 is 7, minus 0.7x equals 10 times 0.5, or 5. So I take 0.3x minus 0.7x, and I get negative 0.4x. plus 7 equals 5. When I subtract 7 from both sides, I get negative 0.4x equals negative 2. Divide by negative 0.4. And divide by negative 0.4. These cancel, and I get x equals negative divided by a negative is positive, and 2 divided by 0.4 is 5. So the question is, how much of each soil was combined? So 5 gallons, x equals 5. And that was my S sub 1. So there was 5 gallons of 30% clay soil. Okay, that was this part. There was, let's move this, my answer is going to be 5 gallons of 30% clay, 5 gallons of 70% clay, making 10 gallons of 50% clay. Okay? Okay, exercise 2. The equation 0.2x plus 0.8, 6 minus x equals 0.4 times 6 is used to model a mixture problem. How many units are in the total mixture? Okay, the total is right here. 6 units. B says what percents relate to the two solutions that are combined to make the final mixture? Well, that is right here. Let's change colors. Right here and right here. So 20% and 80%. The two solutions combine to make 6 units of what percent solution? And that's right here. When the amount of a resulting solution is given, for instance 4 gallons, but the amount of the mixing solutions are unknown, how are the amounts of the mixing solutions represented? Okay, if the amount of gallons of the first mixing solution is represented by the variable x, then the amount of gallons in the second mixing solution would be 4 minus x. Okay, that is the end of lesson 17. Review the lesson summary and go do your problem set.